A and B are two similar cylindrical containers. The ratio between the surface area of container A and the surface area of container B is 4:9. Tyler fills container A with water. She then pours all the water into container B. Tyler repeats this and stops when container B is full of water. We need to work out the number of times Tyler fills container A with water. We're going to start by looking at this ratio here. So for the surface area, the ratio between A and B is 4:9. And what we're essentially looking at here, because they're similar cylindrical containers, is a scale factor. And from an area scale factor, we can work out the length scale factor. And to do that, we need to square root. And we can remember that quite easily, because whenever we're working with an area, we're working units squared. But whenever we're working with length, we're just working with units. So we need to square root to get to there. So if we square root 4 and square root 9, we're going to get 2 to 3. So the ratio of the length is 2 to 3. But now our final goal is we want to get volume. So we can use our trick here to work it out again, because volume is always measured in units cubed. And to get to here, we need to cube it. Okay, so we're going to do 2 to the power of 3 and 3 to the power of 3, which is 27. Perfect, so this here is the ratio we want to work with. And that's because we're working with filling the containers with water. Whenever you're filling a container with something, you're filling the volume of the container. Okay, so we need to work out the number of times that Tyler fills container A with water in order to fully fill container B with water. Okay, so if they fill container up A once, we got 8 of whatever our units are. And all of that 8 is poured into container B. So in container B, we've now got 8. But that's not quite 27, so we need to do it again. So you can fill container A up to 8 again and pour that in. So now within unit B, there'll now be 8 plus 8, so 16. So you can fill up A all the way again and pour that in container B. So that's going to be 16 plus 8, which is 24. Okay, we're still not quite 27, so we're going to have to fill up container A again. Pour that in container B. 24 plus 8 is going to give us 32. Okay, and we stop now because that's more than enough for us filling container B. So how many times do we have to fill container A? 1, 2, 3, 4. So Tyler had to fill container A with water 4 times. So I'm just going to put 4 in the answer box. Okay, so we get our first mark for finding the corresponding length ratio. Then the second one for finding the volume ratio. We got our third mark for this step here. And the final mark for the correct answer of 4.